Hello everyone, I'm Shah Ali Newaj Topu. Um, I'm CTO of BRAC IT. I'm also founder, co-founder and director of Secure Link Service Limited, Selise Digital Platform. Uh, so that's kind of like big titles. I'm not that person. I'm basically a programmer. I have coded all my life. I started programming when I was very young, in school back in 90s. And since then, I have built software all my life. That's the only thing I can do. And like millions of programmers out there, I like to build software. I'm programmers. That's what we do, right? I mean, we build great software with great UI, great functionality, uh, and all that. And then we like to show them off to the world. We want to put in front of people to solve their problem, try to come up with solutions. That is what we do. And then we build these softwares and solutions. And we launch our software. And it doesn't load. And then it keeps loading. And eventually, it says service unavailable. Because building software has become really easy. There are a lot of frameworks, a lot of tools, a lot of low-code, no-code platforms. You can just go out there. Anybody can become a programmer now. You can just go out there and start building a software, get something done, put it online, put it in front of in an app, put it in Play Store. You can have your application running in no time at all. But the thing is, there's the first step of developing a software. You can just build something and give it to a few people, it works. But software at scale, that's a very different ballgame. Software at scale is not easy, it's very difficult, and it's very mission critical. So today, we will discuss about how scalability has impact on us, on anything that we build. So let's take an example of an organization called BRAC. BRAC is the largest NGO in the world. BRAC has over 90,000 employees, and it serves 126 million people worldwide over 12 countries. In Bangladesh only, BRAC has more than 4,500 offices. What does BRAC do? BRAC offers its services to the people who are not catered by our traditional institutions. That's what BRAC does. And who are these people? Like, who is BRAC trying to reach? So BRAC is actually trying to reach the unreachables. They're not reached by anybody else. Let's take an example. There are 1 in 20 people in Bangladesh is earning less than 300 taka per day. BRAC goes to them. They have a program for ultra poor. 1 in every 11 adults in Bangladesh does not have a mentor. They have no access to any kind of financial support from any organization whatsoever. Nobody cares about them. 1.5 million primary school girls, they get dropped off from school. And 60% of children with disabilities, they don't get access to education. BRAC goes out and offers services and value to all these unreachable. What is the medium? How BRAC does that? BRAC does that, the delivery medium, or all the helping elements that help BRAC to deliver this service to all this unreachable technology. And the technology BRAC has to use for these services, to deliver this service, it has to be highly scalable. Otherwise, BRAC will not be able to serve this huge amount of people through technology. So let's take an example, a story of Sultana. She works at a government in Gazipur. She has a financial crisis. She needs to have access to some kind of funding. She hears about BRAC, that okay, I can go to BRAC office and get some service and financial aid, and then maybe she can pay it off within a few months. So to offer this service to Sultana, there are some limitations because Sultana can only get out of her garments for 1 hour during the day. That's the 1 hour she has to get this money. So BRAC, with its scalable ERP and microfinance solution, this is how the service is delivered. So before arriving, Sultana can fill up a form which is helped by BRAC's guy in front of the government itself or a nearby office. Pre-filled form with all her information. This information goes into the system way before she has to reach to the office to get the money. And then a very fast real-time processing. As soon as she goes to BRAC's desk, her information is all filled up. An AI-based system already offers and verifies her need and makes sure she can get the money. As soon as it gets approved, the money goes into her Bkash account. She has the money within that 1 hour. She goes back, buys medicine for her mom, goes back home happy. What if this didn't happen? What if there was this old software that BRAC used to use? So Sultana would see a huge line in front of BRAC's office because the software was not working slowly. It was working slowly. So there was the huge queue. And once she would have gone through that queue at the desk, she would see that after entering her information, the famous circle and turning it around on the screen. Software was not working. She has been asked to come the next day. She cannot come. It's a complete distrust. Nothing works for her. And she'll probably never come back to BRAC again. So that's why this scalability of a solution is extremely important for BRAC. Because BRAC has to serve millions of people efficiently through technology. BRAC has to support its 90,000 employees so that they can perform better, efficiently. It has to offer microfinance and financial services to all these people. There are a lot of emergency relief and emergency actions that BRAC has to take in terms of, say, for example, COVID. And then all these different things, this data-driven decision-making and all, BRAC is completely dependent on technology. And this technology cannot be inefficient. It has to be scalable. It has to grow as the demand grows. So what is scalable technology? Scalable technology is a technology that, as we discussed, it grows when there is a need to grow, and it shrinks when it needs to shrink. It has to scale up and down. And in most cases, the way we build software, that is not our primary concern when we build software. We build software in terms of, say, functionality, UI, and a lot of other things. But if the application scales or not, that is not the primary concern of while developing a software. But when you put software at scale, then your application breaks. I think we have seen this example over and over in Bangladesh in many different areas. Even in the last few months, I think we have seen different banks launching application and failing. So scalability is a huge challenge, and then this kind of scalable technology must have to serve such a big organization. So what are the characteristics of scalable solution? The scalable solution must be elastic. It has to be able to grow as needed basis. It has to be very modular so that load and one part of the system does not affect the other parts of the system. It has to be very modular and distributed. it has to have very efficient resource utilization, because cost of ownership of software is very different when it grows. So it exponentially grows when your application starts scaling. So entire cost of ownership of a software, cloud bills, maintenance bills and all. So it has to be very efficient in resource utilization. It has to be very much fault tolerant, because failure will happen. There are a lot of different reasons for the application to fail. Part of the application may not work. So it has to be able to recover, and it has to be able to start serving as soon as the failure is solved. And then there has to be data scalability. BRAC produces huge amount of data. Right now, we have tables in our system that has 400 million records in one table. In another table, we have over 3 billion records. So all this data has to be handled properly by the system. The question is that how do we build such scalable solutions? Because this kind of scalable solution, I mean, even in most of the universities, these are not taught properly, because universities' job is to provide us information about how to build softwares and like boot us up. But then when you go into real world, we get to learn this kind of technology and patterns and practices. So these are few of the patterns and practices that we need to use to build scalable solution. First one is the domain-driven design. Domain-driven design is a design approach that allows us to break down very complex systems into smaller components, smaller modules, and then find different dependencies between them, and be able to design a system that are very decoupled. And then all these different components are designed by separate team and separate architecture, but has a coherence among all of them. Then, once we have such a domain-driven design system, we can use microservices as an architectural pattern to build our systems, where each of the microservices has its own code base, its own database, and between different microservices, the communication between different microservices are very fault tolerant. There comes the asynchronous event-driven design. So the event-driven design allows us to build softwares in a decoupled way, so that they are not directly connected to each other, but they talk to each other through some kind of messaging service or message bus or an event bus. So that's how we build event-driven system. Then we need CQRS, command query responsibility segregation. So all the data in the system should be segregated from all the change requests to the system. So commands and queries needs to be segregated. So this is another pattern that you need to use to build scalable system. Then you need to use caching. Caching is very important, because we cannot go to database every time when you need data. If some data can be cached, put it in a memory stored cache, so that the application can perform much better with a memory-driven cache. Then we need to have distributed database. Distributed database is something that are not very commonly used in Bangladesh at all, because we all suffer with scale, but with distributed database, what we can achieve that not all our data has to be stored in one database. It can be stored over different database, and we can use distributed transaction modality on top of a large set of database that can serve at scale. And then we need to go for serverless and Kubernetes into cloud, so that our application can also scale. When you have more load, you have more pods scaling out. When you have less load, it becomes a smaller setup. So that's how we build scalable solution. And scalable software is not easy, first of all. It's difficult. It's difficult to architect, difficult to build. It's expensive as well. It has high development and engineering costs. It has probably a bit more infrastructure and scaling costs. Continuous monitoring is extremely important. It's very highly monitored, because in a distributed system, data can go desync, and then you have to put the right places, right tools, so that we can sort those out. And then maintaining performance under high load, that is also very important. So it's not easy, it's not simple, it's complex, it requires a lot of engineering, but that is what we do, right? Then, at the final note, I strongly believe that technology has no intrinsic value. Technology really doesn't matter unless technology can solve someone's problem. Only then, by solving problem, technology can create value. No matter how efficient my code is, no matter how good my database is, no matter how talented I am, nothing matters actually, unless I can build something that goes out there and solve someone's problem, solve Sultana's problem, and it can make the world a better place. Thank you very much.